Hello everyone, so welcome back. So this is lecture 6, week 6 and session 1. We are going to talk about, as the last class we talk about metaheuristic algorithms, right? So those metaheuristic algorithm, this class we are going to be give that more kind of metaheuristic algorithms what use in the healthcare, and how to also talk about two examples to this section. So this is a part 2 about to the metaheuristic algorithm sections. So in this course we are going to be talk about to machine learning can be used to train computers to see, identify normalities, point to point and need attention, thus enhancing the accuracy of all processes. In this class we are going to talk about two different or multiple type of metaheuristic algorithms that use in the healthcare system. So a metaheuristic algorithm, as we know, we already talked about to the last class, that metaheuristic algorithm is the higher level procedure and heuristic designed to find, generate and select a heuristic or partial search algorithm things. So metaheuristics heuristic is a sample of subset of solution which is otherwise too large to be completely enumerated or otherwise explored. So the key examples of this class we gonna be talk about review about two metaheuristic algorithms, then we talk about two kind of the metaheuristic algorithm, evaluationary algorithm, swarm intelligence algorithm, physics based algorithm and inspired algorithm, so on. So this is our contents. We are going to talk that review week 5. First some slides we are going to be revised to what we talked about in the last class, and then we talk about to metaheuristic algorithm, then evaluationary algorithm type of metaheuristics in the healthcare system, swarm intelligence algorithms for healthcare system, and physics based metaheuristic algorithm for healthcare system, and last we are going to talk about to the bio inspired, and after that we are going to be conclude our this class. So in here we can see that what is the metaheuristic algorithm is. Heuristics are a set of search algorithm that can be find a optimal or the best. Optimal means we can find the best solution of giving any problem, giving any hard problem. So metaheuristics are the set of search algorithms that can be find optimal or best solution for a given hard problem efficiently and effectively. So in short we can say that heuristics are the know-hows, the hows that enable use to obtain and best move for the next step. So and metaheuristics are know-hows the enable us to find an efficient way to solving to the given problem. So metaheuristics are higher level strategies that control various type of lower level heuristics sections things. So here is the characteristics of metaheuristics. First, Glover conventions. So Glover convention is provided to all modern nature inspired algorithms, that is metaheuristics. In the Glover convention they provide in 1986, talk about to the nature inspired algorithms. Then we have heuristics. Heuristic is to find or to discover by trial and error, and meta, that is the beyond or higher level, and metaheuristics generally perform the better than simple one, that is the meta. What is the meta word is defining to the meta word is the beyond or higher level, and metaheuristics generally perform the better than heuristic algorithms. So in metaheuristic thing is, metaheuristic is a master strategy that guides and modifies other heuristics to produce solution based those that the normally generated in the quest for the local optimality. That is mentioned these things in the Glover, by the Glover in the conventions, Glover conventions in 1997. And in the remark of this whole sections is the almost all metaheuristic algorithms trained to be suitable for the global optimization. That can be, we can use to almost every metaheuristics, like metaheuristic we talk about to the swarm, evolutionary, bio-inspired, nature-inspired, physics. So those all algorithms are globally optimized, can be used for the globally optimizations for the any problems, to solve to any problems things. So this is the about his to metaheuristics or characteristics of the metaheuristics things. So metaheuristic has a two major component. First is the intensification and diversification, or we can call that exploitations and exploration. And diversification to generate a diverse solutions so as to explore the search space on the global scale, and intensification that used to intensification to focus the search in a local region, knowing that the current good solution is found in this particular region. So for related to the region wise, the intensification, finding that how much intense in the some particular region, and according to those they have tried to solve the issues, solve the problems in optimized way. So these two are the more specific features of, or we call the features, or we can say that the component of the metaheuristics algorithms. So diversification, they can be work in the generate for the diverse form, they can be find the solution for the diversely, or intensification that is also going to use for the some particular reason wise, the solutions things. So a good balance between the intensification and diversification should be found during the selection of the best solution to improve the rate of algorithms convergence. So this is the making the balance between the diversification and intensification. As we see, we can its name itself is defining in intense and diverse. So intensification and diversification, you can in the other manner you can say they both are the opposite of each others. So in here they making the balance between both the intensification and diversification, they must be should be found during the selection of the best solution to improve the rate of the algorithm convergence for the some particular problems. So next we are going to talk about two metaheuristic algorithms in the healthcare. How can we use metaheuristics algorithm in the healthcare system? So let's see. As a brief survey of the metaheuristics healthcare system is given to the learnable big data analytics framework for the healthcare system is presented, and the open issues or we can say that metaheuristics challenges in these things the healthcare system is addressed, or the healthcare system is usually involves various intelligent technologies from the different discipline, and especially for the metaheuristic and data mining things. So we need to make them balance those things to be, it is the biggest challenge to finding the solution on those interoperability methods things. So then the learnable big data analytics framework for healthcare system is presented in the current time. So metaheuristics can be metaheuristic can be regarded as a part of the machine learning and the soft computing technologies, new advanced technologies, or some soft computing technologies related things. So in addition to input and output, the transition evaluation and determination operators will be performed repeatedly until the search process converges or meets the predefined the stopping some conditions things. And metaheuristics have been used by several recent studies on the healthcare system by solving the data mining problems, for example clustering, the unknown data, classification for the part of unknown data, and associate rules for interesting patterns. So these are the healthcare system to use the metaheuristic algorithm in their field. So that's all we reviewed. This all we talk about the last class, our class 5th, and now we're going to focus about to the more in the algorithm point of view. So as we talk about there is a multiple algorithms there is a 4 basic one: evolutionary algorithms, swarm algorithms, physics based algorithm, bio inspired algorithm. So in here we're going to talk those algorithm in more details of things. This last class I promised those things to gonna be talk these all algorithms to how these algorithm can be useful for the bio healthcare systems. So first we have to first topic, that is the evolutionary algorithms. So this algorithm we are going to talk about to the how evolutionary algorithm going to be used in the healthcare system, and what type of some other evolutionary algorithms and how they are processed, those things let's see. So first meta-heuristics algorithm is the evolutionary algorithm in here. So evolutionary algorithm is the subset of evolutionary computation or generic population based on meta-heuristic optimization algorithm. So in short is we going to pronounce in the EA algorithm. So an EA algorithm use mechanism inspired by the biological evaluation such as the reproduction, mutation, recombination and selections, the data and in the data field. So candidate solution to be optimization problem play the role of individuals in the population, and the fitness function determines the quality of the solutions. So as we talk about the evolutionary algorithms of the using the population, then takes places after the repeated application of the above operators. So in here we talk about this reproduction, mutation, recombination and selections things. So those things evolutionary algorithm giving the using with the help of evolutionary algorithm we can find it the what is the changes and how much is this reproductions and those things is happening in the given those healthcare systems. How to they mutate, mutation that means changing, like we can call to mutation is for example that COVID-19 mutate with the COVID Omicron and those things. So changing the versions, so they mutate in the different form, something to that is called the mutations. Recombination is making to like combining 2 or 3 things to data and make it the some new, combining the new data or new disease can be find out those solutions with the help of this evolutionary algorithm, optimizing those solutions things. And selection, need to select the some particular and those specific elements for the algorithms, and those our algorithms, this evolutionary algorithms is used for to implement there. So this is the all about to the evolutionary algorithm, that where is this they providing to candidate is the who is going to use this algorithm to solution to the optimization problem, play the role of individual in a population, and the fitness functions determine the quality of solutions. So evolution of the population then takes places after the repeated applications in the of the above operators. So this is the basic information about to the evolutionary algorithms. Evolutionary algorithm often is perform approximating solutions to all the problems because they ideally do not make any assumptions about to underlying the fitness. They do the trust on the real exact data, and based on those data they are not going to be assume, they're not going to be predict those things, they're going to be provide the solid results. So these techniques of the evolutionary algorithms applied to the modeling of biological evolution or generally limited to the explorations of the micro evolutionary processes and planning models based upon the cellular processes. So the most real applications of the EA's computational complexity is the prohibiting factors. In fact, this computational complexity is due to fitness function evolution, and fitness approximation is the one of the solution to overcome this difficulty. So however, seemingly the simple EA evolutionary algorithm can solve often the complex problem, therefore there may be no direct link between to the algorithm complexity and the problem complexity things. So these are the talking about to the evolutionary algorithms. So here we have some multiple evolutionary algorithm things like genetic algorithms, genetic algorithms, genetic programming, evolutionary evolution strategy, how to we can evaluate those strategies, and differential evolution, neuroevolution, and learning classifier system. So let's see one by one. That first is the genetic algorithm. Genetic algorithm is seeks the solution of problem in the form of the strings of numbers by the applying operators such as the recombination and mutations. So whenever we talk about to the genetic or those mutation things or combinations things, they can be used to this type of algorithms, this type of evolutionary algorithms for that. So it is beneficial for the finding the easy to finding the recombination and mutation problem solving. Next we have to genetic programming. Genetic programming, the solutions are in the form of computer programs and their fitness is the determining by their ability to solve the computational problem. So this genetic programming they using to the providing the solutions with the help of computer programs, with the help of programming, coding, and those things, with their that patient's fitness to determine. There is means fitness, patient's fitness is determined by their ability to solve that with the help of the computational problems things. Third, we have to evolutionary programming. Evolutionary programming is used to similar as the genetic programming, but this the genetic programming, but the structure of the program is the fixed. We give that already decide that their limit and their limitation and all things, and based on those within that limit they gonna be performed. Evolutionary programming algorithm gonna be performed. So this is the similar as the genetic algorithm, but the structure of the program is fixed and numerical parameters are allowed to evolve in this with the help of this algorithms. Then we have to evolutionary strategy. Evolution strategy is the works with the vector of the real numbers as a representation of the solutions and typically uses the self-adaptive mutations rate, finding the percentage or rate of the mutations and recombinations percentage of the to accessing those data. So evolutionary strategy works with the vector of real number as a representation of the solutions and the typically uses self-adaptive mutation rate things. Third, fifth, we have to differential evolution. Differential evolution algorithm is it will be work on the based on the vector differences. What the differences between the vector and based on those data, and is therefore primarily suited to the numerical optimization problem. Numerical optimization problem we can talk about the last class as mentioning what the problems comes in the numerical form. For example, sugar, high blood pressure, there is a range, right? So based on those numerical optimization is this differential evolution using to that type of numerical optimizations problem to the system in the system. So next we have to neuro evolution. Neuro evolution is similar to the genetic programming, but their genomes represent the artificial neural network by describing a structure and connection weight. So the genome encoding can be direct or indirect, that be possible. So this neuroevolution is the same as the genetic one using for the recombination and mutations problem. So but that is it is similar to the genetic programming, but the genomes represent the artificial neural network. They using to ANN, artificial neural networks. So by describing the structure and connections weight describing instruction and connection weight means like whatever we are giving the input, they were going to process, they did those process to within the hidden layer, so they have those connectivity, finding the features. So those connectivity is using to that is connections weight, that is what the when we make the connections between input to hidden layers, they have some connections. So that's connection weight, it will be using describing structure, and connection weights or genomes encoding can be direct or indirect, can be possible to use it. Last we have to learning classifier system. So learning classifier system is here, this solution is set of the classifier, making the rule or conditions. Based on those rule and conditions, they are classified the result. They make the collect the data, and based on data analysis and based on data result, they have to classify the different things. Classified in the making the classification between the those output or data things. So these are the some type of the evolutionary algorithms. Next we are going to talk about to the challenges. Still the evolutionary algorithm has some challenges. For example, a possible limitation of many evolutionary algorithm is their lack of clearly genotype or phenotypes distinctions. It is using the nature is fertilized egg cell undergo or complex process known as the embryogenesis to become the mature phenotype. So the indirect encoding is believed to the make the genetic search more robust and also may improve the evolvability of the organism. So recent work in the field of artificial embryogenic and artificial development, the system seeks to address these concerned things. So and the gene expression programming successfully they using to the gene expression programming successfully explore genotype or phenotype of the systems things. So these are the some challenges of the evolutionary algorithm to using to in healthcare for the mutation and recombinations and other applications field in a healthcare system. So these are the some process how to this evolutionary algorithm had started the work. First like initialization, generation, variation, evolution and selection, and then get the remark. So what is the initialization? If we talk about the initialization is the generate the initial population. For example, initial population that we started from 0, P0, and set the value of I, the value of input I is equal to 1. So this is the using in the initialization. Second, we have to generation. Generation is using to evaluate the fitness of the each individual of populations, and this process is going to be repeat and repeat and repeat till the last population elements not gonna be analyze or evaluate things. Third, variation. Finding the variation is there is generate offspring from the parents using to variation operator to from population of I, that will 1. So that will using that way they are collecting the doing the variation, generate the offspring from the parents using to variation operators to form population 1, there we are population I can be changed. Third, evolution. Evolution is evaluate the fitness of each individual in the PI, and each individual in the PI things, and they are going to find it the single values like from 0 to n, 0, 1, 2, 3, 4 like n values. Still individually they gonna be evaluate each of the fitness of the particular value in the like PI. So evaluate fitness of the each individual in PI. Then selection, they gonna be select the parents from the PI and PI minus 1. So that pi minus 1 based on their fitness. So I is equal to I minus 1 value. That is the exact value of this. For this prompt they are gonna be selected. So this is the last we are gonna remark is giving to the until halting criteria are satisfied. Halting criteria is the where what conditions or what rules we have put it in the system. According to that halting system or according to that rules, they gonna be repeat this process till they not satisfy those criteria halting system. Like we fix that, okay, when we get it the value is 80%, then it's gonna be done. So it is gonna be make it those values to according to this evaluation making to the halting on those criteria gonna be satisfied. So this is the all about to the evolutionary algorithms. Next this session I'm gonna be stop here, and next session we're going to start to talking about to evolutionary algorithms characteristics and other further algorithms for this. Okay, thank you. See you next session.